Okay, in this video, we're gonna look at section 3.6, and notice that we're finishing uh, standard algebra 2.6, which is solving quadratic equations. In the last section, in 3.5, we looked at using completed square. You can see that here it says using completed square to rewrite quadratic function into the form of y equal to ax plus h, should be minus h actually, ax minus h squared plus k, which is a vertical stretch and flip, horizontal shift, and vertical shift, and then graphing that using those information. There will also be some word problem related to that. So for example, we looked at the babysitting with the 50 hours paying $9.50 an hour, and then increasing the hourly rate will decrease the number of hours. So those kind of word problems. Today we're going to look at using quadratic formula and the discriminant to figure out the solution. So we're still solving. Again, when we solve for an quadratic equation, we're looking for the zeros. We're looking for value that will make the statement true. Don't forget to come back to refer to this chapter guide, which is listed in Google Classroom, to see what kind of question you should be able to answer at the end of the unit. So we're still on quadratic functions, and we're going to look at the quadratic formula. Now, I know this is something you have memorized sometime back in Algebra 1 probably, but now that you know how to do complete the square, we want you to be able to derive it from the original general case of ax squared plus bx plus c. So that means that you want to be able to do the completed square process effectively in order to see how you can derive the quadratic formula from scratch. So if you look at the original kind of a standard equation, the first step about doing the completed square is that you want to get rid of a, because completed square doesn't work with a number in front of x. So we divide everything by that number, move the constant term to the other side, and then this is a moment where we complete the square by adding the same number on both sides, so that the left is now a perfect square. And whatever the right side is, you can simplify it to a value, square root both sides, and then end up with this plus minus answer. In the same way, we have ax squared bx plus c. We can do the same thing. So first we get rid of a, just the same way we get rid of the 2 here by dividing everything by 2. So we're going to divide everything by a, and then move the c term to the other side. And this is where we do the complete the square, where we take the term in the middle, b over a, we divide it by 2 and square. This is why you get that 4 on the bottom, because that was b over 2a squared. B over 2a squared is b squared on the top and 4a squared on the bottom, and you do it to both sides. And notice that this b over 2a is where you get the formula for line of symmetry, because it's horizontal shift, so it's always the opposite. So when you shift to the right by this value, or left, you get the negative b over 2a. So anyway, this is where that horizontal shift comes in. This is why you have the line of symmetry formula equal to x equal to negative b over 2a. It's right here in this step. We simplified this. It doesn't simplify as nicely as that 7 over 2, but it still becomes this b squared minus 4ac, which you might be familiar with, because this is the inside of the square root in the quadratic formula. When you square root both sides, you end up with this plus minus square root of b squared minus 4ac over 2a. And then you minus that b over 2a on both sides. And then you notice that the denominator is the same, so you can merge it into one long expression. So negative b plus minus square root of b squared minus 4ac over 2a, which is known as the quadratic formula. Let me do it just one more time. I think this is an important concept to understand, that quadratic formula really is just doing the completed square in a general form so that you can skip all the steps and just plug in those numbers and get straight to the zeros. So I do it from scratch again. We have ax squared plus bx plus c, and we want to solve the equation by solving for zeros. So first thing we want to do is we want to divide everything by a, using capital letters so that it's easier to read, because b, my handwriting, I don't want to make it look like a 6. So divide everything by a. Actually, we're dividing 0 by a too. It's just that it's still 0, right? So a cancels out, end up with x squared plus b over ax plus c over a equal to 0. I'm going to move c over a to the other side, becomes minus c over a. And here's where I want to complete the square. I'll use a different color. I'm going to divide this number by 2, which is b over 2a, and we're going to square that term, and we're going to do it to both sides. So I'm going to go ahead and square that on this side. That's b squared over 2a times 2a is 4a squared. And this completed square allows me to now write this as x plus b over 2a squared. That's why we added that term in the first place, so we can complete a square. This is equal to, I should go back to blue. I'm going to make it the same denominator by multiplying top and bottom of this term by 4a, which is 4a squared on the bottom. So same denominator, and that gives me negative 4ac plus b squared over 4a squared. Okay, we're gonna square root both sides, add the plus minus. This becomes x plus b over 2a equal to plus minus square root of, I'm gonna write the positive term in the front, negative term in the back, so b squared minus 4ac all over. Notice that this is a perfect square, so we can take it out of the square root over 2a. And then finally, minus b over 2a on both sides. X is equal to negative b over 2a plus minus b squared, sorry, that's a b, minus 4ac over 2a. They have the same denominator, therefore x is equal to negative b plus minus b squared minus 4ac over 2a. Okay, so you won't need to know this to do the problem in this section. However, if you can follow along with this process, it will really help you solidify your steps for a completed square, and also give you a kind of a context, the concept of why this formula is the way it is. Okay. So let's look at how to apply this. So when you're given an expression, and again, it has to be equal to 0 because we're solving for 0, then you can plug it into that formula, and then wherever the value is will be your zeros. Notice that it will always be plus minus, so 1 goes to the plus, goes to the right, minus goes to the left, so you will end up with 2 answers, assuming there are two solutions. So let's look at this example. So first, you need to take the expression they give you. You need to write it in standard form, so that you have to move that 11 over and make it negative 11, so that equal to 0. This one, there's no coefficient in front. I shouldn't write it, make it look like a 0, but there's no coefficient in front of x, which means it's the same as 1. So we're just going to use a for 1, that's right here. B is negative 10, so B is negative 10. And then C is a negative 11, so you put that negative 11 here. You put everything in. This number will come out nicely with a perfect square. Square root of 144 is 12. So you end up with 10 plus minus 12 over 2. That means we're going to go to the left and right by that value. And 10 plus 12 over 2 give you 11. 10 minus 12 over 2 give you negative 1. And therefore, the solution is negative 1 and 11. Okay, you can always double check. You should do that on a test to make sure the solution, which makes the statement true, in fact, make the statement true by plugging in x. Let's go ahead and try one of these problems. Let's try 1b. 1b has a 2 in the front, which might make it a little bit harder. Let's go ahead and do 1b. When you're ready, you can unpause the video to see the solution. Okay, so 1b, I have, I'm going to go ahead and write a formula first. X is equal to negative b plus minus square root of b squared minus 4ac over 2a, which means b is 25, so negative 25 plus square root of 25 squared, 625, and then minus 4, a is 2, c is 33, over 2a, which is 2 times 2, is equal to negative 25 plus minus. I'm going to go ahead and put that all in the calculator. So 625 minus 4 times 2 times 33, which equals to 361 over 2 times 2 is 4. This is equal to negative 25 plus minus square root of 631 in the calculator give me 19 over 4, which means I have negative 25 plus 19 over 4, which is equal to negative 6 over 4, which is negative 3/2, or negative 25 minus 19 over 4, which is negative 44 over 4, which is negative 11. Okay, and those are my two answers. So there will be a situation where, so notice that the way the quadratic formula is, you start out with negative b over 2a, which we learned from section 3.1 is the line of symmetry. And then you have this plus and minus, so go to the right and go to the left by the same amount as it should, because the quadratic function is symmetrical. So go to the right from the line of symmetry. So if you have a graph like this, right? And so negative b over 2a, which is right here, give you this line of symmetry. And then this value here with the square root kind of goes to the right and go to the left by the same amount to find you where the zeros are. It doesn't match this graph, but anyway, it's this idea that negative b over 2a give you the line of symmetry, and you go to the left, go to the right by the same amount. Now, if b squared over minus 4ac, if the number inside the square root turn out to be 0, which means you're not going to the left or going to the right at all, then the vertex has to be right on the line of symmetry, which means there will be only one solution. Just in this case, it's just negative 4, because the number inside doesn't take you to the left and right by a distance. This is why the number inside is significant. They have a name for it. It's called a discriminant. If the number is 0, you're going to end up with one solution. If the number is greater than 0, you're going to end up with 2, because it's going to the left and to the right of the line of symmetry. Let me go ahead and move on to the next one. In this case, the b squared minus 4ac for this equation end up with a irrational number. I won't go through that simplifying process here, but make sure you know how to take that 92, make it equal to square root of 4 times square root of 23, which is 4 becomes 2, so 2 root 23, so that 2 can be canceled out with that 4. Actually, you have to divide both of those terms. But the 6, 2, and 4 all are divisible by 2, so that you can simplify it to a most simplified answer. We prefer this answer than the decimal one, so leave it as a irrational solution if appropriate. So let's go ahead and try one of these so we can make sure you can simplify the radical properly. So let's do 3b. Okay, let's start with the quadratic formula, which is negative b. So negative 8 is just a positive 8. Plus minus square root of negative 8 squared is 64. Minus 4a is 1. And c is a 9. Divided by 2a, which is just 2. This is equal to 8 plus minus 4 times 9 is 36. 64 minus 36, that's 8. And then, what's that? 5, 28. 28 over 2. 28 is equal to 4 times 7. So 4 times 7. 4 comes out as a 2. Divided by 2. So this is equal to, cancel out the 2 for both of these terms. 4 plus minus square root of 7. And that's my answer. Complex roots. So when you do the negative b over 2a, if you end up with a negative number, you end up with a I in your answer, and then you simplify it to 3 plus minus I. And this is why we're talking about complex number in this chapter, because this 3 plus minus I is what builds this quadratic equation. Those are the roots. So even though they're not real solutions, 3 plus minus I are the roots of this function. We'll talk more about that in class. But for now, if you have any questions on what that really means, but for now, if you were to plug in these numbers, so 3 plus I and 3 minus I into the original equation, you will see that it actually made the statement true. You'll notice that whenever you have an imaginary roots, that means your graph will not cross the x-axis because it has no roots. It has no real roots, has no real zeros. Let's go ahead and move on. I'll let you practice that on your own. Again, in summary, the number inside, because it's going left and right of the line of symmetry, negative b over 2a, if that number, which we call discriminant, is 0, you have one solution. If it's bigger than 0, you have two solutions. And if it's negative, the square root of negative will give you a imaginary, therefore complex zeros. To summarize over here, when it's greater than 0, you have two real. And this one's also, yeah, perfect score or not, doesn't matter. It's just rational or irrational. But when it's greater than 0, you have two solutions. When it's equal to 0, that means you don't go left and right of the negative b over 2a. Therefore, you only have one real 0. And then when less than 0, you end up with no real solution. So there will be questions where you don't actually have to solve. They just want you to use b squared minus 4ac. You plug in, so b is here, 4ac is ac. And just by looking at the discriminant, you know that this one will have one real root, this one negative, so have two complex or two imaginary roots, and that's it. That's where you will stop. Okay, so let's try 5b, for example. Make sure you know to rewrite this into standard form first, so the highest degree, and then decreasing order of degrees, x squared to x term, and then a constant term, so that when you apply the b squared a for ac, you don't use the wrong coefficient. So we're going to check b squared minus 4ac. This is b squared is negative 7 squared, so it's 49, minus 4 times a is 15, c is negative 4. This is equal to 49, that's what, 60. 60 times 4 is plus 240. this is equal to 289. Actually, we don't need to do the whole calculation because we know this is positive. This is positive, therefore there's two real solutions or two real roots. This slide is a summary of all the things we learned so far in chapter 3. So we started out with solving by graphing and just knowing that these 2 points are the solution for our equation. And then we look at factoring to build a root either by giving you the 0 first, and then you, if this is P, this is Q, write this as x minus P, x minus Q to build the equation, so factoring. 2, using the completed square and square root to solve. And finally, what we do just now using quadratic formula. There we go. This is the homework for 3.6. Let me know if you have any questions when we meet in class. Thank you for watching.